Welcome dear student and Jai Swaminarayan. In the first lecture of the chapter number 3 atoms and the molecules, we had discussed about atomic theory, view of the different scientists regarding atomic theory, and more precisely the Dalton's atomic theory, the postulates of the Dalton's theory, atomic theory, right? So according to the Dalton's, right, the atom is the smallest particle of the matter. Atom is a very thin, very smallest particle of the matter, right? So this atom, what is atom? In this video we will discuss about the what is atom. So atom is the smallest particle of the matter. So if we consider that matter, all the matters are made up of the molecules are made up of the atoms. Now what is atom? So atom is the smallest particle, indivisible particles of the matter. So dear student, in this video we will discuss about what is the atom, what are the symbol of the atoms of the different elements, how we can calculate the atomic mass of the atoms, right? What are the properties of the atoms of the different elements, right? So let us start with the what is atom. So in the previous video we were discuss about the what is an atom. An atom is the smallest particle which can indivisible is called the atom, right? So let us start. An atom is the smallest particle of the element that may or may not exist independently and retains all its chemical property. So the atom is the smallest particle of any element. If we consider the any matter is made up of the smallest particle, that is called the atoms. Here the atoms of the element may or may not exist independently. The atom may exist independent, or the atoms may not exist independent, and the atom retains all the chemical properties of the element, right? So here the atom is the smallest particle of the element that retains all the chemical property of the element, right? Atoms are very small in a size and smaller than anything we can imagine and compare with, right? So atom is a very tiny teeny particles, very smallest particles, smaller in the size, right? It is a smaller than anything we can imagine. If we dividing any matter, keep going divide, if we get the smallest particle of the matter, and this smallest particle of the matter is also made up of the atoms, right? So atoms is a very small in a size. So the size of the atom is measured in the nanometer. So dear student, here size of the atom is measured in a nanometer. Nanometer is the unit of the length, very smallest unit of the length, right? So atomic radius of the atom is measured in a nanometer. So dear student, what do you mean by the nanometer? 1 nanometer, it is equal to 10 raised to minus 9 meter, or we can say that 1 meter is equal to 10 raised to 9 nanometer. So dear student, let us understand that what do you mean by the 1 nanometer. So 1 nanometer is equal to 10 raised to minus 9 meter, right? So that is a 1 divided by 10 raised to 9 meter. So if you take a one thread of a 1 meter and part this thread equally in a 10 raised to 9, that means after 1 there is 9 zeros, right? So 10 raised to minus 9, that is equal to the 1 divided by 1,0,0,0,0,9 zeros. So if you part a 1 meter thread into the equal part 10 raised to 9 part of the 1 meter thread, one part is called the 1 nanometer part. So dear student, here 1 nanometer is equal to 10 raised to minus 9 meter, right? So the atomic radius of the atom, right? Atomic radius of the atom, hydrogen atom, lithium atom, helium atom, all the atomic radius of the different atoms are different, right? And it may be measured in the nanometer. So here the atomic radius of the different element like a nitrogen, atom, oxygen atom, argon atom, hydrogen atom, carbon atom, helium atom, krypton atom, this all the type. So here the atoms are connected with the other atoms and make a structure, it is called the molecules, that we will see later on. But the atomic radius of the different element is measured in a nanometer. So understand, dear student, what do you mean by the 1 nanometer? 1 nanometer is equal to 10 raised to minus 9 meter. That may be asked in your examination in a fill in the blanks, in the MCQs, right, in a short questions. That so this one is very important. 1 nanometer is a 10 raised to minus 9 meter, right? So the atomic radius of the atom of the hydrogen is about a 10 raised to minus 10 meter, right? So the radius of the molecules of the water. Water, you know, the water contains the hydrogen atom, 2 hydrogen atom and 1 oxygen atom. So the atomic radius of the molecules of the water is a 10 raised to minus 9 meter. So the atoms, by the several combination of the atoms, we get the molecules, and molecules are several molecules are made a matter, right? So dear student, understand what do you mean by the atom? Atom is the smallest particle of the element. The size of the atom is a very small. The size of the atom is measured in a nanometer. 1 nanometer is equal to 10 raised to minus 9 meter. The atomic radius of the hydrogen atom is a 10 raised to minus 10 meter. So what are the modern day the symbol of the atoms of the different element? How we can represent the atoms of the different element? So Dalton was first scientist to use the symbol for the elements in very specific sense, right? So first the Dalton was given a symbol of the different atoms, elements, symbol for the elements in the specific sense. So Dalton gives the hydrogen, the symbol of the hydrogen like this, right? In the screen, the symbol of the different element is present, proposed by the Dalton. When he used a symbol for an element, he also meant the definite quantity of that element, and that is the one atom of that element. So here, by representing a symbol of the different element, Dalton was taken a care of use a symbol of an element by with the definite quantity of that element, one atom of the that element, right? So here in this figure, right, the symbol for the some element that are proposed by the Dalton is given. For example, here for the hydrogen, the symbol of the hydrogen atom is like this. The symbol of the carbon atom, the symbol of the oxygen atom, the symbol of the iron, silver, mercury, right, platina, lead, sulfur, phosphorus, copper and gold. So the Dalton proposed the symbol of the different element like this, and they were used at that time. So dear student, draw this all the symbol of the elements that are proposed by the Dalton. But nowadays, the more and more as the time is going on and on, more and more elements were found, right? And it is difficult to manage the difficult to draw the symbol of all the elements, right? So now in the beginning the name of the element were derived from the name of the place where they were found for the first times, right? For example, the name copper, the element copper was taken from the Cyprus, right? Cu. So the here how we can represent the symbol of the different elements in the modern days, right? So now as the previously the Dalton was first given a symbol of the some different elements, but as the time is going on and on, new and new elements were found, right? And it is difficult to give the symbol of each and every element. So at that time in the beginning the name of the element is given by derived from the name of the place where they were found for the first time, right? For example, element copper, copper was found in a Cyprus, right? So the copper was taken from the Cyprus. Some names were taken from the specific colors, right? So some of the name of the elements were taken from the place, right? Some of the name of the element is taken from the specific color. For example, gold was taken from the English word meaning a yellow, right? So this way, the different from the different color, from the different place, from the different characteristics, the name of the element is given. But nowadays, International Union of Pure and Applied Chemistry approve the name of the elements. So IUPAC, this name is called the IUPAC name of the elements. So what do you mean by the IUPAC? International Union of Pure and Applied Chemistry. So that may be asked in your examination, what is the full form of the IUPAC? IUPAC, that means the International Union of Pure and Applied Chemistry, and the approves the name of the element, and that is called the IUPAC name of the element. So many of the symbols are first one or two letter of the element's name in the English. So according to the IUPAC name, the many symbol of the different elements are taken as a first one or two letter of the element's name in the English. The first letter of the symbol is always written as the capital letter, that means the uppercase letter, first ABCD, right? And the second letter as a small letter, that is a lowercase letter. So according to the IUPAC name of the elements, according to the IUPAC, International Union of the Pure and the Applied Chemistry, right, the symbol of the elements are the first one or two letter of the elements name in the English. First letter we must take a capital letter, and the second letter is a small letter, right? So the symbol of the elements are represented by a letters. So nowadays, according to Union of Pure and Applied Science, the symbol of the elements are taken from its name. First one or two letter from the name of the element, right? First letter we consider as a capital letter, and second letter we take a should be a small letter, right? So according to this IUPAC, symbol of the some elements are given in the textbook also, right? So you must have to remember this symbol of all the elements. Like first one is the aluminium. The symbol of the aluminium, Al, first two letter we take a symbol of the aluminium. So we take a capital and L a small. Argon, Ar, barium, Ba, boron. So in the symbol of the boron we take only B, right? So boron, to represent the boron element we use the symbol capital B. So again next is a bromine. Bromine, the symbol of the bromine is a Br. Calcium we use the Ca. Carbon we use a capital C. So here if you use the calcium capital C, the element is a carbon, and if you write a capital Ca, it is the element calcium, right? Chlorine Cl, cobalt Co, copper Cu. The symbol of the fluorine is taken as a capital F. The symbol of the gold is a capital AU. The symbol of the hydrogen is a capital H. The symbol of iodine is a capital I. The symbol of iron is a Fe. It is taken from the ferrous, right? So the symbol of the lead is a Pb. The symbol of the magnesium is a Mg, capital M, small g. Symbol of neon is a capital Ne. Symbol of the nitrogen is capital N. The symbol of the oxygen is capital O. The symbol of the potassium is capital K. The symbol of IUPAC symbol of the silicon is a Si. So IUPAC symbol of the silver is a Ag. IUPAC symbol of the sodium element is a Na. IUPAC symbol of the sulfur is a S. IUPAC symbol of the uranium is a capital U, and IUPAC symbol of a zinc is a capital Zn. So other elements are there. So in the future you will study the more elements and the symbol of their elements. So this symbol of all the elements are taken from the IUPAC symbol. So this symbol is called the IUPAC symbol. We cannot change this symbol, right? So according to the IUPAC, the symbol of the atoms of the different element are represented by a letters, right? The symbol of the some elements are represented by a one letter, and the symbol of the some elements are represented by a two letter. So if the symbol has only one letter, it should be written as a capital letter, right? So if the symbol of any element is written one letter, it should be a written as a capital letter. For example, if we take a boron, so boron we write a capital B only, carbon we write a capital C only, right? Fluorine we take a capital F only, iodine we take a capital I only. So if we represent the symbol of the elements only one letter, we should be written as a capital letter. But if the symbol has two letters, then the first letter should be capital and the second letter should be a small letter, right? So if we write a two letters of the name of the elements, right, first letter should be a capital letter and second letter should be a small letter. For example, barium, so barium, for the symbol barium we write a capital B small a, cobalt capital CO, right, silicon Si. So understand, dear student, so you must have to remember this all the symbol of the elements. So we need to represent the any elements in their symbolic form, right? So dear student, understand the symbol of the elements, right, of the different elements, atoms of the different elements, right? You have to remember, you should be remember this all the symbol of the different elements, right? So now how we can calculate what is the atomic mass? So atomic mass is the mass of the atoms, right? So since the atoms are very small in a size, its a mass is a very small, and determine its a mass is very difficult, right? So how we can measure the mass of the atom? Atom is a very small particles, right? So it is difficult to measure the mass of the atom. So the mass of the atom is measured with the help of the special technique that is called the mass spectroscopy. So here the mass of the each atom of each element can be measured with the help of the technique called the mass spectroscopy, right? And the instrument that measures the mass of the atom is called the mass spectrometer. So the mass of the mass of an atom is a compared with the mass of the standard atom, right? So here the mass of the atom is measured in the atomic mass unit, that is the standard atom, right? Standard unit of the atomic mass is the atomic mass unit. It is represented by small u or AMU, right? The atom which is considered as a standard atom for comparing the mass of the other atoms is a carbon 12 atom, whose atomic mass is a 12U, atomic mass unit, right? So the atomic mass is should be measured in a unit of a atomic mass unit. It is represented by AMU or only small u. So the here to measure the atomic mass, we must have to compare the mass of the atom with the standard atom. That is the standard atom, we take a carbon 12 atom, right? So one atomic mass unit is, what is the 1 AMU? What is the one atomic mass unit? One atomic mass unit is the mass of the 12th part of the mass of the carbon atom, right? So AMU is the unit of the atomic mass, and atomic mass of the atom is measured in the unit of the AMU. It is a very small compared to the normal mass. So what is the 1 AMU? So 1 AMU atomic mass is the mass of the 12th part of the mass of the carbon 12 atom, right? So here atomic mass unit is a 1/12 of the mass of the carbon atom, right? So atomic mass of the element is defined as the average mass of the one atom of the element compared with the 1/12 of the mass of the carbon 12 atom. So here the atomic mass of the different element is given to you. So dear student, here the atomic mass of the some elements are given to you, and you must have to remember this atomic mass of the different elements, right? So here for first element is a hydrogen. Atomic mass of the hydrogen is a 1 AMU, atomic mass of the carbon is a 12 amu, atomic mass of the nitrogen is a 14, atomic mass of the oxygen is a 16, atomic mass of the sodium is a 23, atomic mass of the magnesium is a 24. Similarly, atomic mass of the aluminium element is a 27, atomic mass of the sulfur is a 32, atomic mass of the chlorine is a 35.5, and atomic mass of the calcium is a 40. So the atomic mass of the other elements you will study in the further in this chapter, or in the higher study you will understand the atomic mass of the different element. So for here you have to remember this atomic mass of the all the different unit, right? So dear student, understand what do you mean by the atomic mass? Atomic mass of the an atom is a very small in a size, right? Mass of the atom is measured with the help of the techniques called the mass spectroscopy, right? Mass of the atom is measured in the unit of the AMU, atomic mass unit. So one atomic mass unit is a 1/12 part of the mass of the carbon atom. So here the atomic mass of the some elements is given to you, so you must have to remember this atomic mass of this all the elements, right? Now, how does an atom exist? Atoms of the most element are not able to exist independently, right? Atom cannot find a independently. Atoms form some molecules and the ions. They are these molecules or ions aggregates in the large number to form the matter, and that we can feel, see, feel or touch. So dear student, here the all the matters are made up of the molecules or the ions. Molecules and ions are made up of the atoms. So we can say that at most of the elements, for the most of the elements, atoms are not able to exist independently. All the atoms of the same element or the different elements combines together forms some molecules, right, or ions, right? These molecules or the ions in a large number to form a matter, and matter we can see, feel or touch a matter. So how the atoms of the same elements or the atoms of the different elements forms the molecules and the ions, we will see in the next video. What is the molecules, how the molecules forms, right, for the different atoms, right? So same element atoms of the same, how the atoms of the same elements form the matter, what are the chemical properties of the elements, that all the things we will discuss in the next video. So dear student, keep watching my video for the what do you mean by the molecules and how the atoms forms the molecules.